related for the losses only, or both pump and losses. Okay, fine. So this is the equation for what? Energy equation. As we see, the first part of this equation is Bernoulli, but we continue or complete the equation by other functions like pump, like turbine, and losses. Let's go for substitution here, also apply here. Horizontal pipe carries 30 cubic feet per second of water. So here this is Q. Pipe is water. At A, the diameter is 18-inch and the pressure is 10 psi. At B, diameter 36. So we have two diameter, different diameter at A, diameter at B. This diameter is A cross section. This is B cross section. For A cross section is 18-inch. For B cross section, this is 36-inch. This is 10 psi. And the other one is 10.9 psi. Determine the head lost. So he requested here what? Head lost. Anything mentioned for this problem? No. No pump, no turbine. So B over gamma plus Z plus V square over 2G equal no pump. So B over gamma plus Z plus V square over 2G plus head of losses. Great. One question, why we put here pump in this side, turbine and losses on the other side? Because head of pump normally add energy to the flow. Means the flow coming from the outlet side, add energy for this flow to obtain another energy. But turbine, no, turbine is consume the energy from the input, and this is the remaining here for the output. Losses as it is. This is the output remaining after some losses from the initial energy. You understand me? Okay. So apply. First pressure here is 10 psi divided gamma. Here all units is British, so not usually gamma for the water for British, take it as 62.4 and G for British 32.2. This is a British unit. This is pound force per feet cube. This is feet per second square. So this is unit is what? Pound force per feet cube. So we can write it here 62.4, but be careful because this is pound force per feet cube. But the up here is pound force per inch square, PSI, pound per inch square. So it have a different units here, so needed to convert units. I will back for this to convert units, but just wait. Z here, he mentioned horizontal pipe. I know that also for Z. Horizontal means the same datum. So if takes this the datum to measure the Z. So ZA is the same datum, which is 0. ZB is the same datum, which is 0. So cancel horizontal, this cancel with this. Velocity, unknown velocity. V A cross section A squared to G to multiply 32.2. As a pressure is 10.9 psi divided the same gamma 62.4 plus V square B by 2 multiply 32.2 plus head losses required. But still we have another unknown velocity. I will show you how to get it. First here, this is to convert it from psi to pound force feet cube or feet square. Need to change inch square to feet square. So inch to feet is 12. So inch square to feet square multiply 144 multiply 144. Another point, how to get the velocity from, I tell you, normally the equation for continuity is all the time is contact with the Bernoulli or energy. Q, happy face, is equal AV. And as per continuity, the QN equal Q out. So I can, this is Q constant here. So I can calculate VA equal 30 cubic feet per second divided area by over 4. Diameter is 18, but 18 what? 18 inch. So divided by 12. Divided by what? 12. This is square equal, this is velocity. Velocity B, 30 cubic feet per second by over 4, 36, divided by 12. Sorry. Wow. Instead of -44, 62.4. Z cancel with Z. V square, which is V square over 2G equal 10.9, 144, 62.4, V square B, this is A, by 2G to multiply 32.2, plus H loss. And we discuss for the velocity, VA is equal Q, which is 30 by over 4, 18 divided by 12 square, and VB 30 by over 4, 36 over 12 square. From this equation, you have VA, you have VB. Going to substitute here for this equation. The only unknown is what? H loss. If you have any equation for this problem, tell me. Okay, fine.
Sir, for this pressure 10 psi, we got per pressure where from inch to feet. We should divide or multiply with the
Multiply. Bound
they're doing
inch square. So this is bound per inch square. So we needed to change it to inch square here, feet square. And to change from inch to feet divided by 12. Correct? Like for example, 5 inch, you need it to be feet divided by 12. Correct? Which is mean this inch, feet to inch. Here 1 feet, 12 inch. So we divided 5 by 12. So here this is opposite, inch square by feet square. So 1 feet square is equal 144 inches square. Okay. All is fine.
so we will divide or multiply.
Multiply.
Okay.
Okay, fine.
Fine.
A pump draw water 50 Fahrenheit from reservoir where the water surface elevation is 520 feet. This is the elevation for the state 1 here. And forces the water through a pipe 5,000 feet long. This is the length of the pipe. 1 meter in diameter. The pipe then discharges the water into the reservoir with the water surface elevation 620. This is the final elevation The rate is 7.85 cubic feet per second. This is the flow rate. And the head losses, it can be follow this equation. This is the head losses equation. Determine the head supplied by pump. You need head of pump. So we need to apply energy equation, including pump. So first write the equation, B over gamma plus Z plus V square over 2G. This is for state 1 plus head of pump equal B over gamma plus Z V square over 2G. You have losses? Yes, they give you equation to calculate the losses. This is for state 2. Let's start. The pressure for 1 is open to atmospheric, correct? This is open to atmospheric. So the pressure here for the surface, atmospheric. If it checks the another side, is also open to atmospheric, so atmospheric. Cancel the same value. Next. This is what said reservoir. For reservoir, it's have option. What is this option? Diameter for reservoir, very large. Very big. So velocity very small, which is almost 0. So the velocity here for state 1, 0. Velocity for state 2, 0. Both in reservoir. So the remaining here Z 520 plus head of pump. Here is Z 620, the elevation here. Head of losses. Head of pump is equal 620 by 520 is 100 plus head of losses. Head of losses, you know value, he gave you equation to calculate it. So write the equation point 01 L over D V square over 2G. Let's take erase the element, substitute L 5000 D 1. So back. This is 5,000 feet. This is 1 feet. Also, this is a calculation for this one or this one is also feet. No problem. So we are going to you are follow the correct units. What else? G velocity. It's not given direct. $32.2 for British velocity. How to calculate it from this charge. Happy phase. What said happy phase? Happy phase said velocity is equal Q over area due to equation of happy phase. So Q is 7.85 cubic feet per second. Area by over 4, diameter square. What is diameter? 1 feet. So 1 square. You got the value for the velocity. Once you have a value, going to substitute it here. Don't forget this is velocity square because many going to lose this square. Forget it. Okay. That's it. And going to substitution for the velocity and continue to solve. You obtain head of pump 178, which means the part of losses only 78 feet. Any question? A pump as shown in figure take water from 200 millimeter suction pipe. Here, this is suction pipe, 200 millimeter diameter. Delivers it to 150 millimeter discharge, in which the velocity is 2.5 meter per second. Here, velocity 2.5 meter per second. At A, in the section pipe, the pressure is minus 40 kilopascal. A B is a discharge pipe, which is 2.5 above A. The pressure is 410. What horsepower would have to be applied by the pump if there were no friction losses? No losses here. He mentioned here no losses. You need what? You need the horsepower required. To get the horsepower, which is a power of pump, is equal gamma UH. H for what? This is the head of pump, HB, which is can be calculated from energy equation. Q discharge, gamma is specific weight. Okay, gamma, as we know, no problem. This is British or SI, so 9810. Coming from where? Rho G, rho 1000, and G is 9.8. So this is gamma. Great. What else? Q and head of pump. Q is flow rate, which is can get it by continuity. You happy face. How to get it? By continuity. AV. You have velocity? I have a velocity for section B, not A. So you can calculate it by section B. Area you have, yes, I know the diameter, pi over 4. Diameter 15 millimeter, which is 0.15 square meter. And V is 2.5 meter per second. From this equation, we calculate what? Meter cube per second for this discharge. So now we gamma, we have a Q by easy way. Easy given, easy way, easy substitution, everything is clear. So what's next? Head of pump. To can talk about for head of pump, apply by energy equation. Let's go to apply. B over gamma plus Z V square over 2G state A head of pump B over gamma plus Z plus V square over 2G. Any losses? No. He said no friction losses. Section B. Let's apply to check available data and unavailable data. Piece pressure, okay, avail minus 40 kilopascal, so it's better to be Pascal, 10 to the power 3. Gamma, I can write it as it is, or I can write it 9.81 multiply 10 to the power 3. I prefer here to write it as it is, 9.81 multiply 10 to the power 3. Why? To cancel 10 to the power 3 with 10 to the power 3 to reduce the calculation. Z. According to your datum, I take the datum here and the measured distance from here. So if you take datum at A, so Z is equal 0. It is on the datum. Velocity of A not given, but we can calculate it because we know now Q. I calculate the Q here by this data. So from this is at cross section B to be aware which A and which B from. Here V of A, so V of A square, I will go to calculate it. 2.981 head of pump. Other side pressure is 410 kilopascal, so 10 to the power 3. Gamma is 9.81, 10 to the power 3. Plus velocity is 2.5, this distance. Plus velocity for section B is given 2.5. Please don't forget to make square. 2 multiply 9.81. Which one is the unknown head of pump? And also VA we need to search to calculate it quickly first. So going to calculate it first. We write it here, calculation for VA. VA is equal Q by area. What's Q? This is according to your calculation here for the Q. So go to substitute it here direct. This Q. Area by over 4. D is 200 millimeters, so 0.2 meter square. From this equation, you can calculate VA, substitute it here. Don't forget again square. Once you calculated the head of pump, just multiply head of pump and the Q and the specific weight to get the pump. No question? This is the conclusion for the power of the pump. This is what I need actually, this equation. Gamma Q H. Okay, this is the power of the pump. Efficiency, we already discussed the efficiency before for question coming. I think theoretical question. Efficiency is power output divided by power input. Output by input. For the pump, what is the output? The energy in the fluid, because you add energy into the fluid. And what is the input power? This is the electricity. I just run the pump. Due to the input power, I give electric input power to obtain hydraulic power. Pump efficiency, as per discussion here, output by input. So according to that, if you talk about for pump, this is pump, where is output? This is output. Input, this is the input. So output divided input. That's it. But if you talk about for the motor, so output of motor 900 divided by 1200, which is input. If you talk about for the whole system, the final output, which is 648, divided by initial input, which is 1200. And sometimes for some problems, they give you the efficiency of motor direct as a value, efficiency of pump as a value, and he requests efficiency overall. So this is equal efficiency of motor multiply efficiency of pump. Okay. Can he sometimes examiner repeat for this question by the another two elements, efficiency for generator, efficiency for turbine. You see me now, if it is multiply here, divide here. No, also this one multiply this one, efficiency of turbine, multiply efficiency of generator. Hydraulic and the energy grid line. What's meaning here for hydraulic and the energy grid line? Any point is have energy. This is energy, it is the total energy for the point. Great. But due to movement of the flow, the energy is divided in two parts. Part related for the static, part related for the dynamic. So we said the part of the static, it is hydraulic, represented by hydraulic line. And the part for not only dynamic, no, dynamic with the static as a total. This is energy grid line, like energy total. So here we have, for this case, for example, this is what is this tube, normal tube and the L shape, normal tube and L shape. What is measured here? Velocity. One for stagnation condition. What happened for the stagnation condition? A measure total head, which is referred to total energy. And the other one, just a little. He measures static only. Measure what? Static. So one measure total, one measure static. And all the time we talk about for this point. What is the difference here? Total minus static, as per the equation, H static plus H dynamic or H total. So static plus dynamic equal total. You have a total and you have a static. So the difference between total and static is equal what? Dynamic, which is referred to V square over 2G, the part of kinetic energy. If I take beta tube and I put it at different location of the pipe, what we'll find? The energy grid line, which is referred to the total energy, is going to decay like this. Due to what? Due to losses. Due to what? Due to losses along the pipeline. Accordingly, the other line, hydraulic grid line, is going to be also with a slope to be parallel with the original initial reducing for the energy grid line. So energy grid line and the hydraulic grid line both is going together slowly with the same distance. Keep it the distance the same. This is for all application or different. Let's see. This is referred for what? Energy grid line. Total. This is referred to what? Hydraulic grid line. Static. What is different? The part of dynamic V square over 2G. So the part here of this distance is referred to the dynamic V square over 2G. When this distance changed, let's see, refer to what this distance V square over 2G, which is constant below in the denominator G, and upper one is variable velocity. So when the velocity change, you can check this can be changed or not, this distance. Velocity can change according to continuity if diameter change, because continuity is said what? AV. So we can, for different area, it means this is different velocity. Let's see, for example, this case, for example, for normal pipeline, so the two parallel line for energy losses, this is total energy and static energy, both go through parallel from start to the end. But another case here, this is the pipeline. What happened here at this cross section? I make increasing for the diameter, increasing for the diameter. Maybe you feel this is better to be relaxed, whatever. Not all the time like that. You are convert from the low to here, low diameter to high diameter. What happened? According to continuity, this is inversely proportional. If the diameter increase, what happened for the velocity? For sure decrease. This is what is happening here. The velocity here is the same. What happened here? This is the initial or the first condition. The second condition, due to this one here, expansion happened, velocity decrease. So it's decreased here at this cross section and to continue again with the same difference. So at the beginning here, go through to the same difference up to this intersection to change it. Once you change it, is continue also with the same distance. Continue also with what? The same distance. So all in all, what is the meaning of difference between energy grid line and hydraulic grid line? This is referred to velocity, or dynamic head. Friction factor, the last equation today, important, very important for the part of pumps. Friction factor, actually here, I write the equation here. The first one we studied here referred to Darcy-Weibach equation. Darcy-Weibach equation. This is the head of loss. What is Darcy-Weibach equation? This is said the head of losses is equal to F L over D V square over 2G. If you remember the problem we're solving, which is given the equation for losses calculation, is almost the same. He give you 0.01 F L over D V square over 2G. The 0.01 is the F actually. What is F? Friction coefficient. What is F? Friction coefficient. This is referred to the fraction factor calculated from chart to represent the losses. Okay, this is length, this is diameter, This is velocity. This is constant G. Actually, this is a part of losses, not all losses, used by Darcy-Weber equation. Can be used for calculation of losses, said major losses. This is in pipeline. You said me, but this is normally what's coming. No, not all the time. Sometimes the loss is not only for pipeline. Sometimes the loss is for pipeline and the fitting used. T, elbow, valve, whatever. Okay. For this case, we have another part is minor. So it's coming for minor or just focus for major? No. In exam, sometimes the problem coming for major only, sometimes coming for minor only, sometimes for both. It means problem coming for only calculation of minor? Yes. So the equation general, this is one. The first part here for the losses in the pi, which is Darcy-Weber, FL over dV square over 2G. But the second part here refer to the losses in the equipment component, K V square over 2G. This is easy, V square over 2G. Clear, V square over 2G. Also here we have V square over 2G. Normally the problem coming in the exam plus T here in this calculation not, is the same for this calculation, which is mean I can take it as a common factor. V square over 2G as a common factor and remaining here F L over D. I can write sum if you have different pipeline diameter or whatever, plus sum of K, K1 plus K2 plus K3. What's K1 for valve, for example? What's K2 for T? What's K3 for something like this, elbow, whatever. Okay, he give you all Ks. This is given. So according to this equation, now this is conclude the total losses, which is major and minor, major and minor. This should be memorized. This equation should be memorized. That's clear. This is the head loss. What is different between this and this? What is delta B? Sometimes in a little problem, ask for pressure losses. I don't need to save a lot. What you will do? The pressure is general equation. Pressure is equal rho GH or gamma H. So if you talk about for pressure losses is equal gamma for the flow, head of losses. So what we'll do, take this to substitute here for general equation of losses and substitute for this equation to get the value for head losses. Once you get the value for head losses, substitute for this equation, another equation, multiply to gamma to get the pressure. So don't save a lot of equation. The pressure required, no problem. I will back and call the equation in my mind for the losses, general losses, head losses. And once I got it, I multiply for the gamma. That's it. Any question here? What is the dimension for Darcy fraction factor? No idea? Share with me answer, share in the chat, whatever. Darcy fraction factor, which is F, dimensionless. Water at 25 liters flowing through 1 kilometer long GI pipe. So here, this is the sum of the fluid, water, 1 kilometer long GI. millimeter diameter at the rate of 0.07. Value of Darcy fraction factor 0.02. Density of water 1000. The pumping power. What is power of pump? Gamma U H. So gamma, this is property rho G, rho 10 to the power 3, G 9.8. Q given. So what is remaining? How to get it into pump? Yes, energy equation. B over gamma. The second part, B over gamma plus Z V square over 2G. This is state 1, state 2. Do you have losses? Yes, for sure. We have F here. Losses. That's great. Let's go. Pressure. No data here for this equation for pressure. So consider as we start atmospheric and we end atmospheric. Z, no data for elevation, which is considered as horizontal pipeline. Velocity, for sure we have velocity, but the diameter for the pipeline 200. Diameter, a change between state 1 and 2? No. So if diameter change, why velocity change? So no velocity change. Someone tell me, no, nothing in equation. No. We create another one now. Head of pump is down, drop. Head losses, we don't drop like this. You can divide head losses to the initial equation for this. What is head losses calculation? F L over D V square over 2G. This is what? Losses. Only that it should be plus K V square over 2G. But any data here for fitting or component or whatever, no. So no need for minor losses, only major. We talk about for major here. So it means the pump required to cover the losses only. Let's go to substitution. F 0.02 L 1 kilometer here. So 10 to the power 3. Diameter 0.2. Velocity, it's not given direct from Q. So happy face, I will use it. 2G to multiply 9.8. Great. So stop step here for velocity. Q over A. Which is equal, Q is 0.07. A by over 4. Diameter, which is 0.2 square. From here, you can calculate velocity to substitute it here. Once you substitute, you can get it the head pump. Once you get head pump, substitute here for this equation to get the power. Any question? Any question? Small pipe of diameter 200 millimeter carry water. The pressure in the pipe at section S1, elevation 10 meter is 50 kilopascal. Then going to section 2, without any change of diameter. So diameter is the same for the pipe. Something like this of the pipe. This is S1, this is S2, and they give you data for the S1, which is elevation 10 meter, pressure 50 kilopascal. Other one here, Z 12 meter, pressure 20 kilopascal. Diameter 200 millimeter. Also give you the velocity 2 meter per second. Density, acceleration. What is required, which is true? What is true? The flow is going from S1 to S2 and loss is 0.5. S2 to S1, loss is 0.5. S1 to S2, loss is 1 meter. S2 to S1, loss is 1 meter. So we have two questions actually. The head loss is a value and the direction of the flow. 1 point. Some engineering tell me the flow for sure is going from the high level to low level. Okay, but if you check here between high level and low level, you will find the pressure, it is opposite direction of the Z. If just going to the numbers, which is mean you can take a decision for which is dominant here, which is affect more the different elevation or different pressure. Because if you check pressure only, you found the direction of flow. It is opposite for if you suppose to depend of Z only. Clear? You understand me? So it should be solved mathematically to can check which is more affect, this one or this one. That's fine. Let's go. How to write the equation? General equation between 1 and 2, B over gamma plus Z V square over 2G or state 1. Any bump, something like this? No. B over gamma plus Z plus V square over 2G, state 2. You have losses? Yes, this is required actually. So H losses. But 1 point, please. Why we write the losses here in the second side? Actually, you don't know the flow from 1 to 2 or from 2 to 1. And we know the losses, you will add it in the second side, in the low energy side. So I will tell you something. What's your opinion? If you're going to suppose losses as usual, what is usual location? In the second term. Okay, and what next? If we get the losses positive value, so what we suppose is correct. So at this moment, the energy go from 1 to 2. The flow is moving from 1 to 2. But if the losses, you got it negative, which is the opposite for what you suppose, at this moment, it means should be on the other side. So it means the direction of the flow from 2 to 1. You got it, my idea? Okay, let's go to substitute. Pressure here is 50, 10 to the power 3. Gamma is rho g, which is 10 to the power 3, 9.8. Z, 10. Velocity. We have a velocity value given, but don't lose time. Diameter not a change between the two cross section, 1 and 2. So velocity is the same. The value here is the same value here. Pressure second side, 20. Z, losses. It is easy cancellation problem. So 10 to the power 3 is 10 to the power 3, 10 to the power 3 is 10 to the power 3. 50 by 9.8. Consider as 1, not a 10. So 50 by 10 is 5 plus 10. 20 by 10 is 2 by 12 plus 12 equal losses. So H losses equal what? 15 minus 14 equal 1 meter. Positive? Yes. For means first, what you suppose is correct. Flow from 1 to 2. Losses 1 or around 1, approximately 1. So you are in these two sides, 1 and 1. Direction S1 to S2. So answer is C. If you have a question, ask me. No question? Fine. Modi chart. Just I will present you and just describe you the lines here refer to what? Because it's coming in theoretical questions. This chart, yes, but by easy, I will show you what is the question coming. But understand first what is the term is here referred to. 1 moment, please.